Hi guys. So again, if you're following along in the book, we're on chapter 12, and chapter 12 is Introduction to Collections, and in particular stacks. So in this chapter, we're going to look at collection terminology. We're going to look at the Java Collections API. We're going to look at the abstract nature of collections, and then we're going to look at stacks, which both conceptually and how to solve problems, and then an implementation of them using arrays. So a collection is an object that holds and organizes other objects, and it provides operations for accessing and managing its elements. So there are many standard collections that have been defined over time. Some of the collections are linear, and some of them are nonlinear. So here we see an example of linear collections and nonlinear collections. So the linear one is the one that's in a line. The other one looks something like a tree. I'm sure you guys have all seen trees. Tree is a type of a collection we'll talk about later in the class. But it's a tree and it's nonlinear. All right. So an abstraction, the word abstraction in computer science is something that hides the details to make a concept easier to manage. So all objects are abstractions in that they provide a well-defined operations, which we usually call an interface. So the interface is the set of functions that you can use, as opposed, well, there's different different definitions of that, right? Like it could be the interface, like the Java interfaces, which is just a set of functions that's defined as part of a class that you use, that you implement in your class. But also more generically, we can say it's just a set of operations that we can use to interact with an object. So what these functions do is they hide or encapsulate, we say encapsulate the object's data and the implementation of the operation. So the idea is here that we tell you how it works, and we don't show you how it works. You have no idea how it works internally. We just give you an interface. We say, this is what this does. These are what these functions do. And this object has certain properties. But you really don't have an idea of what is going on internally for the object. And that's a good thing. You're not supposed to. You don't need to know. In fact, a lot of times you can actually swap these things out at runtime. You could decide, oh, I'm not going to run. If you have a well-defined interface, you can actually swap different implementations out underneath. And what implementation is underneath doesn't matter to you at all, because all you're really interested in is how do I interact with it, right? The details of what it does underneath don't matter to you at all. There are many, many examples of this in programming. For example, you've got a sound card, right? Like, how does your computer know how to write to every sound card that's imaginable? There's a driver that implements an interface that's a standard interface that all the sound card drivers implement, and that interface lets you do things like send audio to the sound card, or read from the microphone, or do different signal processing effects if it's able to do that. Now, how that works underneath, you have no idea, right? You have no idea what's going on, and it would vary from driver to driver to driver. You swap out the sound card, still all going to work the same from the computer's perspective, because it's just calling those interface functions. And then underneath the driver, the code in the driver is doing something. The operating system doesn't care what it's doing, but it is, so it's encapsulating the data, what the state is, what kind of hardware there is underneath it. That's all encapsulated. It's not important for the operating system. All it needs to know is what the interface looks like and how to use it. So an object is a great mechanism for implementing collections because of this. So a data type is a group of values and the operations defined on those values. So we have some built-in data types in Java, like integers and floats and characters. But we also have user-defined data types, right? Like objects. So sometimes these are called abstract data types. It's a data type that isn't predefined in the programming language. This is kind of I don't think this is a really accurate description in my opinion. Abstract data type is usually sort of the abstract idea of how a data structure is implemented. Like, how does it work? Like a stack. How does a stack work? And then the data structure itself is the set of programming constructs and techniques that are used to implement the collection. So the ADT is the idea of, it's sort of like the interface to the data structure, and then the data structure itself is the implementation, and you don't care about how it's implemented underneath as long as you know how to use the ADT. And again, the problem here is that the words ADT, data structure, and collection, these things are blurred in casual use. In fact, you know, a lot of collection is really a Java term, and a lot of programming languages, we don't call them collections. We just call them data structures or data types, or in C you'd call them like STL classes. There'd be different things that we would call these things. A collection is kind of a Java-esque term. So other languages like C# call them collections, I think. And some languages don't call them collections, though. But they all have them. All right. So a class that uses a collection interacts with it through a particular interface. So we have a class that uses a collection, and we have a class that implements a collection, and in between those, we have the interface. Just like our sound card example, you know, how, for example, a stack, which we're going to talk about exactly what a stack is later, works internally, how those things are stored internally is actually not important to you as long as it behaves the way that a stack is supposed to behave. There's a lot of different ways that you could implement that. The actual way that you implement it doesn't matter as long as the behavior is correct. From the class that's using the collections perspective, it only cares that behavior is correct, and the behavior is defined by defining the interface that the class implements for the collection. So, as you probably know, there are various classes in Java that are provided that are called the Java API, the Application Programmer Interface. There's a subset of those classes that support collections that's called the Java Collections API. So as we explore a particular collection, we'll also look at any support provided in the Collections API for that collection. So there's a lot of these things are sort of built into the language. You still need to know how they work, right? You still need to know how to implement them. You still need to know how they work. Even though they've been implemented in other places, you need to know what you're dealing with, right? And part of being a programmer is just knowing how to write these things. All right, so a stack is a collection that's used to help solve many types of problems. So a stack is a linear collection whose elements are added in a last in, first out manner. Last in, first out. So what that means is the last element put on the stack is the first one to be removed. So you think about this like a stack of books where you add and remove from the top, but you can't reach into the middle. Or you go to the cafeteria and they've got those stacks of plates, right, that push down. You put another plate on the top and you push it down, and it disappears down into the bottom. Like, you can't touch the ones in the middle or the one in the bottom. You can only pull the one off the top, right? That's what a stack is. You push something in, and then the first thing that you pull out is the last one that came in. So we say LIFO, last in, first out. All right, so it's a last in, first out collection, but it's linear. So things are like in a line. They're not in a tree or anything complicated. They're just stored in a line. All right, so the stack collection conceptual view, we see this. We've got the top of the stack. It's a stack of things. We add an element in. We pull an element out. The element that we remove is the last one that we added, and we add on top of the stack. Okay. So conceptually, this is what a stack is. So we have some stack operations that we usually define for these things. We have very particular terms that we use for them. So these are the classic ones. Push, which is, again, like, think about a stack of plates, like in the cafeteria. You push the plate onto the top of the stack. That adds it to the top of the stack. You're pushing the stack down and adding another one in the stack, right? Or like a Pez dispenser. If you've ever seen a Pez dispenser, you push that in the top. And all right, so the next one is pop. Pop removes an element from the top of the stack. So push and pop are the two that you use most of the time. You're pushing something in, you're popping one off. When you pop one off, it takes the last one that you did a push on. So if you push something in and then you pop it off, you get the one that you just pushed. Peek lets you look at the element on the top of the stack. So peek just lets you look on the element on the top of the stack. It tells you what it is. It doesn't pull it off the stack, but it tells you what it is. So you can look at the value. So let's say you have a bunch of integers that you're pushing on the stack. You're pushing, the user's typing them and you're pushing them on the stack. Peek will let you see what the next number is on the stack, but it doesn't pull it off of the stack. All right. It's just it's like a passive look, like you're looking down in there to see what it looks like, right? So is empty lets you know if the stack is empty or not, and size determines the number of elements in the stack. So these are sort of the classic operations. Depending on the language, these things are implemented in different ways. A lot of languages add a bunch of things to let you do things to abuse the stack metaphor. But these are the standard classic stack operations. All right, so that's the end for this discussion, and we will pick this up in a second.